Okay. Hello, everyone. Good to see you again, and thank you very much for joining us today. My name is Nguyen. I'm Technical Application Specialist at Dolomite. So today webinar is one webinar series we call Microfluidics 101 with Dolomite. And this will be on every last Thursday each month along 2021. So today, the topic of webinars is emulsion stabilizer. So we will learn about what is emulsion stabilizers and how to use in microfluidic production. So the agenda today will be including a presentation, and after that we move to the Q&A section. So if you have any question during my presentation, please feel free to write down the question in the question box. So we will directly to answer to you in the Q&A section. So the content of today's webinars is including what are emulsion stabilizers, what are the different types of stabilizers, and how do I know which stabilizer to use, and finally some example application. So the first, what is an emulsion stabilizers? The emulsion stabilizers are any materials that lower in the interfacial tension between two immiscible fluids, which enables an emulsion to vanish without droplet coalitions. So in simple terms, the emulsion stabilizers is any materials that can stabilize or emulsion during the droplet generation. Some example of emulsion including soap bubbles, which is gas in waters, or mayonnaise oil in water, or salad dressing is oil in water emulsion, and emergent is water in oil emulsion. So for specific application like micro encapsulation, so the encapsulant is dispersed in droplet phase, so there's requires a suitable emulsion stabilizer to form the capsule as well. So what do stabilizers typically look like? Actually, the emulsion stabilizer are also called surfactant. So it's a surface active agent. So the surfactant are frequently defined as having a hydrophilic end, as you can see in here, and the hydrophobic end, it usually is the hydrocarbon change. So the surfactant sits at interface between the fluid to easier to form droplet and stabilize the emulsion. So if you have a look in this one, so example, the water in oil emulsion and how a surfactant is placed in interface between the water and oil. So in this case, the hydrophobic end will cover the droplet in the water in oil emulsion. Another oil in water, so the droplet will covers by the hydrophilic end in droplet. Here is showing some examples. One example to see how it's important to design the right surfactant. So in the left-hand photo, you can see in here is the olive oil in agro without surfactant and without making emulsion. And this one, right-hand photo showing the mayonnaise, it is stable emulsion of the olive oil and agro. So, is this important to design the right surfactant? The first case showing the insufficient surfactant has been used when running droplet generation. So the surfactant is not enough to stabilize the droplet active formation. So it leads to the polydispersed emulsion. And the second case in here, you can show it's showing the optimal surfactant use. So in this case, the surfactant is enough to stabilize or covering the droplet and stabilize the droplet, and it leads to the monodispersed the emulsion after droplet generation. So the type of emulsion is including showing some actually the most liquid emulsions are the comprised of an oil phase and water phase. As you can see in here is oil in water emulsion or water in oil emulsion. So in oil and water emulsion, so disperse phase will be oil and continuous phase water, and water in oil emulsion is disperse phase water and the continuous phase oil. So what you are trying to encapsulate and target this medium, we typically detect emulsion type as well. So the common emulsion phase will be including the aqueous or hydrocarbon oil or fluorocarbon oil or silicon oil. So in this common emulsion phase, the fluorinated oil showing the advantage is with immiscible with both hydrophilic and hydrophobic phase, and also it good for working with biological materials which may be both hydrophilic and hydrophobic. However, it has some weak point like it's expensive. And silicon oil showing the advantage like it's a heat stable and non-toxic and low static, and the silicon oil in water emulsion usually used for example of lubricant or cosmetics and personal care product. And with a different stabilizer tailored for each type of interface as well. So next, we will talk about what are different types of stabilizers. Here, showing some type is a type of stabilizer, which including the simple. It could be the simple molecules which have a hydrophilic end and hydrophobic end, and or it could be the polymer of block copolymers, as you can see in here. So it has a high or large molecular weight as a surfactant, and another type is non-ionic, so it means that no charge between at the hydrophilic end of the surfactant, and with or it could be the ionic, which have cationic like positive charge at the hydrophilic end of surfactant, or an ionic, so it have negative charge at the hydrophilic end. And or it could be the digital ionic, so it have both positive and negative charge at the hydrophilic end. Or it also could be nanoparticulate. We call it the Pickling emulsion. So it is kind of using the particles to stabilize the droplet. So if you have a look at this one, it's showing the scheme for the oil water classical emulsion in the left hand of the photo. So in this one, the oil will be stabilized, oil droplet will be stabilized by the surfactant in the water phase. And with Pickling emulsion, instead of the surfactant simple molecular or polymer or ionic or non-ionic surfactant, so they use Pickling or particles, solid particles to stabilize. So we call it the Pickling emulsion. So this one showing some example of emulsion stabilizers. So the sodium dolichine sulfate SDS is ionic surfactant, or it could be a simple molecule like oleic acid, or non-ionic surfactant like twin 20 is polysorbate 20, or span 60, or like surfactant monosteroid. Or it could be the polymers like polyvinyl pyrrolidant or polyvinyl alcohol PVAs. It could be the Pickering's stabilizers, emulsion stabilizer like fluorophane. It's our product, which contains the nanoparticles of the silicon oxide. So how do I know which stabilizer to use? Actually, the most important factors in stabilizers, emulsion stabilizer, is the hydrophilic lipophilic balance, HLB. So the HLB will give a measure of the balance between the hydrophilic and lipophilic hydrophobic properties. So if you have a look at these photos, so with the high HLB values higher than 10, number 10, so it suggests that the molecule is over hydrophilic, so it's water soluble. So it's will be used to stabilize oil in water emulsion. because it's very easy to dissolve in water. With low HLB values like less than 10, it suggests overall lipophilic or hydrophobic properties. So it means it's oil soluble, and it will be used to stabilize the water in oil emulsion. So as well as the type of the emulsion form, so HLB is useful indicator of which phase to disperse the stabilizer in. However, HLB only tells you about the surfactant, not system being stabilized. So there's no any guarantee of stable emulsion formation. So just using as a guide to for surfactant selection. So let's talk about the first type of the surfactants, is ionic and non-ionic. Non-ionic surfactant have no formal charge, so it will be rank of the HLB, and it's generally the biologically friendly, and it's also commonly used in the food industry. So some example of this kind of surfactant is span, twin, or Tristan X100. An ionic surfactant, it contains head groups such as the sulfonates or carboxylates or phosphates. So it has a high LV values, and it will include steroid, which comprise a significant portion of the global surfactant usage. And it found in household detergents like soap or shampoos. For example, like sodium stearate or sodium dodecil sulfate is an ionic surfactant, and the performance of this kind of surfactant will be affected by the value of the pH or temperature. So when these factors to change, so the performance of this kind of surfactant will be changed. The cationic surfactant is often contains the ammonium head group, so it has a middle or high value of the HLB, and it used in antimicrobials and antifungal product, which disrupt cell membrane of the bacteria or virus. So, for example, the CTAB, the cetine trimethylene ammonium bromide, or benzalkonium chloride, the example for cationic surfactant. The second type, the surfactant type talk about here is span and twin. So actually, this is trademark strength of sorbitant esters and ester and ethoxylate sorbitant ester respectively. So the numbers of the hydrophilic tail group, so it will in turn affect of the HLB value. So for example, twin 60 has a monosteroid tail group, or twin 80 has a monooleate tail group in here, you can see, or with the twin 25 has 3 monooleate group here. So it's very popular surfactant due to the generally recognized as safe status and FDA is approved, and also it's low cost as well. And it's good for general purpose stabilization, but can often be improved upon where high performance is required. For the polymers and block copolymers, so in this case, much larger molecules that wrap around the droplet surface, and it's also very flexible in terms of composition, so it can be designed for specific type of the emulsion. And it also slower to diffuse to interface and can be harder to remove when for the bulk. And it can change logical properties of fluids and behavior less easier to predict by HIB value. So in this picture showing some example to how to see it's very flexible in terms of composition and its effect on stabilization of the droplet. So in this case, PEG is polyethylene glycol chain, and PLA is polylactic acid. So when we use this to stabilize water in oil emulsion, when we change the composition exchange PEG and PLA. So we can get a different the density of the surfactant we can absorb on the surface of the water. You can see in here. And the last one is the Pickling emulsion. The Pickling emulsion is we can call it it's a kind of particle, using the particle to stabilize the droplet, and it's rather than the molecular stabilizers. And it can flexibly control the properties of particle during the synthesis of different emulsion behaviors, and its resulting interface is dimensionally large and affect transit of molecular between the two phase. So it can be used to control like sustained drug release from emulsion in topical treatment, or it will be reduced crosstalk. We reduce the crosstalk between the droplet content of different compounds. However, it has some weak points, including the regulatory concern over particle size and number of stabilizers, and also is very it's difficult to scale up due to it more difficult to in manufacture. Stabilizer blend. So when a single surfactant may not effect offer to optimal emulsion stabilization, so we need to concern about using combination of the stabilizer to obtain the best approach. So most commercial detergent and soap will contain a mixture of the stabilizers, so it needs to deal with different oil and composition as well. And also, if the stabilizer is one stabilizer is not providing effective on those emulsion stabilization, so we need to consider the combinations of the surfactant type. So let's talk about some example in microfluidics using surfactant. First example is encapsulation of biological materials. So in this case, the droplet must be aqueous because the support, because of the biological media should be supported by the aqueous phase, and its continuous phase typically the fluorinase in this case. So we consider about the application for single cell analysis to prevent the droplet crosstalk. So in this case, we use the Pickling emulsion, which create a strong barrier to prevent the molecule entering or leaving the droplets. So it's a very useful surfactant for encapsulation of biological material. So for droplet PCR analysis, so in this case, the sample will need to heat it repeatedly during the PCR process. So the thermal stability is the emulsion of the emulsion is the key factor. So we need to choose the surfactant which have good thermal stability for this application. And the candidate for this application is non-ionic molecular or polymeric surfactant. It may offer high stability during the PCR process. So another application example in here is encapsulation of the API, active pharmaceutical ingredient, in PLGAs, PLGA polymers through a DCM in water emulsion. So in this case, the PLGA will be generated with mixing with the API in the PLGA phase, and to making droplets with in DCM as the to disperse in DCM and make a droplet the DCM in water emulsion. So process is a solvent extraction driven, so it needs to be able to relieve the solvent from the droplets, and the polymerics molecular solvent prefers over, like for example, like Pickling the emulsion, and the changing the droplet surface area when the DCM extraction process happens. So it requires stabilizer need to be flexible during that process. and also it considers the nature of the API. So it means it's want to avoid bleaching into the continuous phase. So for solar polars, the API or hydrophobic of the API, hydrophilic of API is maybe we need to use the multiple emulsion. So we need to make a water in oil in waters multiple droplets. So it means we need to have to stabilize the two interface to stabilize, and also it needs to be able to stabilize both liquid droplet and solid bit as well, because first time to formation of the droplets, it should be liquid droplet, and after solvent extraction it should be the solid particles. And it also may want to wash stabilizer from PLGA bit after drying. So our Dolomite produce an aqueous phase for stabilizing the droplet of the PLGA solution in DCM. So it has the blend of the polymer surfactant to optimize the stabilization. Or we could use some another polymers surfactant like PVA to in this process. Here, showing the example for PLGA solvent extraction. So in here is PLGA and DCM's droplet, and after time, so DCM will be extract from the droplet and we generate finally create the PLGA bit in water. So another next examples is introduction of gas bubble to add neutral buoyancy. So the gas bubble usually typically stabilized most effectively by higher HLB surfactants. So it should be hydrophilic surfactant. So with low value of the HLB, hydrophobic surfactants is used as an anti-foaming agent. So in this case, typically detergent surfactants such as SDS are ideas for gas in water emulsion. For the gas in oil emulsion, because both gas and oil are relative hydrophobic, so typical foaming agent will not work as well in this case. In this case, we should choose the Pickling emulsion to stabilize the emulsion formation of the gas in oil emulsion. Summary. So there are a lot of the emulsion stabilizer to choose from. So understanding the way different types of stabilizer function will guide you your selection for the stabilization the emulsion. And the indicators such as HLBs are very useful guided, but it's not absolute. And be aware of the other application areas stabilizing similar type emulsion, and also consider using a blend of stabilizer to get the optimal the stabilization process. Okay, I finished my presentation here, and the webinar Q&A section will start now. If you have any question, please write down your question in the question box. I will try to directly respond to all of you. Thank you. So please write down the question. If you have a question, please write down in the question in the question box or chat box as well. So we will try to answer on the question. And also, after this webinar, the next webinar will be focused on the topics is chip locking and how to avoid the chip locking during the microfluidic production. So if you have any interesting on this topic, please visit to our website and have registration for next month webinar. Is there any question? I hope the content of this webinar today will help you very much on your emulsion creation with your application. So actually, it's we have very wiring and wide area to use surfactant in the application. So for specific application, it would be using the specific the surfactant. So, but the content of today, which will guide you, hope that guided you on your process. Okay, I got one question from the Samatha says, thank you. So you mentioned that for the droplet PCR, you would recommend a non-ionic molecular surfactant with high thermal stability. So is there any surfactant you would recommend in particulars, given that fluorophase Pickling emulsion? Yeah, actually, so for PCR, we recommend a kind of Pickling or emulsion. As actually in here we can let back to in here. So yeah, actually when you're making application you use a fluorophase, right? So for the application with your biological analysis, the biological media. So in this case, you will use you will use a Pickling emulsion to stabilize this. So with this one, actually with the Pickling emulsion, it's also showing some kind of very stable thermal stability during the PCR analysis. So without that one, another non-ionic molecular or polymer surfactant is we can offer the high stability during the heating GPT process. So maybe another type of surfactant we can separate it in PCR. So it would be you can choose some polymeric surfactant has high stability, high stable properties, like yeah, for specific applications, this one I should check it carefully before recommend to you actually, because yeah, just a lot of surfactant could be used for this process and polymers, but for specific application like PCR, I should yeah. So okay, I should check it and will respond to you in the specific in the private emails. So after this webinar, yeah, thank you for your very good question. Any question more? Okay, so I cannot see any more questions in here. So if you have any further question next time, please feel free to share the question through the emails that we attach on the chat box, hanoioffice@blacktrade.com. So we will try to answer you all of the questions later. So yeah, if there's no more any question today, so I would like to stop this today webinar. And again, thank you very much for attention today, and I'm looking forward to seeing our views and next webinars with the topics how to avoid blocking chip during your microfluidic processing. Thank you very much.